Afternoon, dear colleagues. My name is Georgi. I'm a senior researcher at the Institute of Continued Media Mechanics of the Russia Academy of Science. I want to present you the result of our work on the topic research on regularities of deformation behavior of building structures in the areas of technogenic impact caused by mining. Construction and operation of various structures on the territories of mineral extraction requires solving a large number of technically complex problems. This is due to the fact that the development of mineral deposits can cause significant deformation in the overlying ground massif and provoke catastrophic deformation processes in the objects that are located in this area. This impact on building structures is unique and has not been accounted for by the construction project. The deformation field forming on the Earth's surface is very heterogeneous, and the rate of deformation changes are also non-uniform. The formation is influenced by processes that are implemented in the depths of the soil mass during normal orientation of underground facilities. That's why provision of safe operation of facilities located on such territory is an important and urgent problem. The methods of estimation of the stress-strain state of the system's building foundation soil, which are given in the normative literature, establish some rules for design and operation. They allow taking into account the existing technogenic processes in the soil mass or require special structural reinforcement measures in case to control deformation characteristics of the building exceed the limit values. However, quite often it turns out that the existing building has been designed without taking this factor into account. And the changed state of the environment make it necessary to evaluate the possibility of its operation on the basis of deformation processes accumulated by now in the whole system. This work was motivated by the need to assess the operability of large array of residential buildings and other construction sites located in the town of Berezniki, which is located on the territory of Versnikamskaya potassium salt deposit. The slide shows the Versnikamskaya potassium salt deposit in the Perm region of the Russian Federation, as well as a plan of developing the seams beneath the city of Berezniki. Over a long period of time, certain sections of the city territory have experienced significant vertical displacements. As of 2022, the vertical displacement of some parts of the urban development was about 1.3 meters. In 2007, 2018, several ground failures were registered in the urban development area. The slide shows the distribution and orientation of horizontal strains of the surface layer of the soil massif on the territory of Berezniki, according to the forecast for 2025. The picture shows zones of tensile and compression strains. The values of strains intensity vary from 1 millimeter per meter to 8 millimeter per meter. It can be seen that the maximum values are confined to the failure zones and maximum strains gradient is observed exactly there. However, it's worth enough to the zone with a large strains gradient are areas where the population has been evacuated and building has been resettled. Areas of urban development where the intensity of strains is lower and reach value of 3 millimeter per meter on average are exploited. Therefore, it's very important to closely monitor the condition of structures and be able to predict their deformation behavior. That's what this study is devoted to. Based on experience of observing the state of the urban building massive for more than 15 years, we can say that one of the most negative types of deformed state for building structure is stretching along the long axis of the building. This deformed state is not designed. Structures are not able to absorb and compensate considerable forces that occur in structures when such deformed state is realized in the vicinity of their foundations. The slide shows a diagram of such a deformed state for a structure. This type of deformation is characteristic of structures that are located in the tensile zone of the soil massive sheath zone in the mining area. Using the finite element method, a series of computational experiments were carried out, and a large number of boundary value problems were solved to simulate the deformation behavior of the building foundation soil system. Structures of various storage standing on foundation of various type were simulated. The stress-strain state of the building structures, depending on the amount of deformation of soil mass in the vicinity of their foundation, which simulated the effect of mining, was assessed. The slide shows typically boundary conditions for the problems to be solved. The analysis of numerical experiments made it possible to obtain the dependencies of the stress-strain state of the load-bearing elements of structures on the deformations of the surface layer of soil in vicinity of the foundation. Relevant in solving these problems is that the deformate state of the load-bearing elements was modeled as a process of transition from the normal stage of structure to the subcritical and critical stage of structure. These solutions were made in a nonlinear formulation, taking into account the stage of application of boundary condition. The William-Warnke model was used as a model of concrete behavior. The slide shows the distribution of the third principal stresses in the frame elements of one of the structures. The soil is not shown. It's also possible to see a picture of intensity of total strains for one of the stage of deformation of load-bearing assemblies at the stage that precedes the destruction and loss of load-bearing capacity. An energy criterion for assessing the transition of load-bearing elements to the critical stage of deformation is proposed. Based on the analysis of the strain energy and the evolution of the relative stiffness of the supporting elements of the structure in a given volume, the characteristic stage of the deformation behavior of the structural elements can be distinguished. The slide shows the dependencies of the strain energy and the relative stiffness for a part of a load-bearing column of the first level of a monolithic reinforced concrete structure. In the graph, the line number 4, which corresponds to the linear elastic model of the column elements, is shown in green. The remaining lines are solution for the physically nonlinear material properties of the columns for different forms of loading. The graph of the evolution of relative stiffness clearly shows the points that characterize the stages of deformation of the load-bearing structural element. Stage 0A is linear elastic deformation. Stage AB, fracture of the tensile zone of concrete. Stage BC, precritical deformation. Stage CD, critical deformation and loss of bearing capacity. Particular attention is paid to the study of the form of deformation interaction between the foundation of the structure and the soil in its base. The slide shows the result of the assessment of the stress and strain state of the bearing units of panel buildings in the area of platform joints along the length of the structure. The results are presented for different variants of modeling the conjunction of the foundation slab with the ground in foundation. You can see the table on the slide. We can see that as we take into account the nonlinear components of the strain interaction with the ground at the foundation of the building, the amount of deformation of the ground mass which the building is able to absorb without significant losses increases. Values of 7 mm per meter no longer seems to be critical and even allow you to continue to exploit the structure in special cases. The normative document, however, forbids the operation with values higher than 1 millimeter per meter or the length of the building. The result of many years of observation and of the verification tasks shows that proposed evolution of algorithms and the result of the work are in good agreement with each other. The data proposed in normative literature need to be corrected. This slide presents the main points of the work, and I'm done. Thank you for attention.